Hello, everybody. I hope you can hear me. Welcome to our next talk. Good morning, good night, good afternoon, depending on where you're from. Our next talk will be, hello, Bruno. Thanks for joining us. So this talk will be about producing customer-ready parts, navigating the leap from prototyping and production to production. A little bit about Bruno. Bruno is the managing director of PostProcess. He, prior to joining PostProcess, he has led the sales and business development at HERE, providing location-based services in the automotive, enterprise, and consumer markets. Bruno's previous roles include Nokia and Navteq for almost 15 years. Prior to that, he has held various sales and management positions in high-tech multinational companies, including Dupont de Nemours. I'm sorry if I butchered that French, Bruno, you tell me, where he started his career. Bruno holds a Master of Science from Arizona State University and is a graduate engineer from INSA Lyon and a graduate from the INSEAD International Management Program in France. Bruno, I'll leave it with you. For all of us that are listening to us right now, I would recommend feel free to go to the Q&A section to leave your questions, and we'll be going over them with Bruno later. Thanks so much.
Very good. Good morning, good afternoon, or good evening, wherever you are on the planet at this stage. I'm very pleased to discuss with you how we move from prototyping to production in additive manufacturing and make sure that one can produce customer-ready parts at scale. In fact, the previous presentation laid some pretty good grounds for this presentation, because really a number of the challenges that were mentioned, I will go through them today. I'm actually leading the international operations of PostProcess Technologies based out of Nice in the south of France. So what we're going to go through today is a quick state of the market, what are some trends and realities of today's AM when it comes to scaling, what are the opportunities for automating the last step of the process, which is post-printing, and making sure that you enable additive for being production ready through ensuring a continuity of the digital thread. And I think we'll leave some room for conclusion and Q&A. Just a couple of words about who we are. PostProcess Technologies is a global company. We are based in the US with operations in Europe and also very recently opened in Japan. Our sole mission is to create technologies that enable customer-ready 3D printed parts at scale. So we really focus on helping additive scaling their operations. We have no limitation with respect to the technologies that we serve. With a lot of work being done in automated support removal, resin removal, powder removal, and also various surface finishing technologies. And you have here a couple of examples of before-after parts in PolyJet here and FDM. But we do, like I said, many other technologies, SLS, CLIP, DMLS, DLP, SLA, MJF, etc. If you look at the current status of the market in additive when it comes to moving to production, there is a scale-up problem. In fact, many people have said that post-printing was the dirty little secret of the industry, and it is actually correct. You don't really see what's happening in post-printing. Very often you see very nice printer room and the post-printing area is somewhere hidden in a dark room that you don't show to your visitors. But the reality is that this is really an issue when you start to scale, because currently post-printing is using I would say very low-tech technologies. You're talking about picking and sending, using traditional tumblers, traditional spray system, water jets, etc. And that comes with a lot of issues. That comes with obviously a lot of time being consumed, inconsistency of results, breakage, which can be pretty high, in particular with additive when you print very sensitive parts, and overall very expensive process. In general, the industry tends to think that about a third of the overall cost of a printed part is spent in post-printing. Clearly, this approach cannot scale because of all the tribal knowledge, which is at play here in this step. In fact, we have done a survey, we do that every year, but the latest survey on the post-printing that we conducted at the end of 2019, and where we asked the customers, what are your biggest challenges in post-printing? We really see that. We see that the length of time to finish the parts is the biggest issue, but also the consistency of the finished parts, one being different from the other one because of the manual way of finishing that. The throughput is a challenge, and also the damaging of the parts, and basically also the fact that you use labor that you could really use at much more added value tasks. So we really see these problems of post-printing when we also survey our customers. In addition, when you have two steps of the manufacturing process, which are digital, and the third step, which is manual, you basically break the digital thread. And clearly, when you want to ensure that additive manufacturing is a truly digital manufacturing process, this breakage at the first step completely undermines all these efforts to make sure that you move towards a modern production process. And that comes with its own challenges. Obviously, scalability is one, but also sustainability, traceability. When you speak about building parts for aerospace or building parts for medical, traceability is absolutely essential. The more manual steps you will throw at that, the more you would lose in traceability because you will lack data. And with that comes issues with quality insurance. All issues which are absolutely not acceptable when you move to production. When you do prototyping, you can accept that. When you move to production, and when in particular, one wants to think of replacing traditional manufacturing processes, such as injection molding, with additive manufacturing process. Traditional manufacturing has already found ways to ensure scalability, to ensure traceability, to ensure also, in many cases, sustainability. And the companies that are going to move towards additive manufacturing are not going to lower the standards with respect to these elements. So it is absolutely essential that additive manufacturing lives up to these expectations. But the reality is that today, if you want to scale in additive manufacturing, you need to throw people at the problem. And instead of preparing a truly digital additive manufacturing process, instead of preparing for being Industry 4.0 ready, additive manufacturing actually goes back in time by using methods that were at play at the beginning of the 20th century. So that's not the way to go. What you really need in AM is a fully digital manufacturing process end-to-end, where you are digital in the print, which is already the case, digital in the design, but also digital in the post-print. This provides an end-to-end automation. This provides intelligence along the way where data can be shared from design to post-print and back from post-print to design, so that the post-printing element, how you get to the final part, can actually also inform not only the way you print the part, but also the way you design the part. At the moment, parts are rarely designed for post-printing, and this needs to absolutely change. So how do we go about that at PostProcess? We go about it with providing a full stack which is data-driven, made of hardware, obviously, and we have hardware for support removal, resin removal, powder removal, surface finishing. I already explained a couple of these before. Detergents and media, we need that to ensure that there is a mechanical, but also in some cases a chemical action on the parts to remove the excess material that need to be taken out to get back to the intended design, but also software. And software is not only to automate the process, but also to connect the post-printing element to the rest of the digital manufacturing chain. We have today a number of customers. We have actually more than 170 solutions in the market at 90 plus customers. We're approaching 100 customers, both in the US and also in a couple of European countries. And our customers are seeing transformative results from using our technologies, basically enabling them to provide customer-ready parts at scale. You have some examples here on the picture in metal, in polymer as well. So what I'm talking about here is already market tested. Our technologies deliver day in, day out results for companies that are scaling their additive manufacturing process today. What our customers see typically is much higher consistency. You have repeatability from part to part because fundamentally everything is data-driven and automated. So there is no black magic or digital or tribal knowledge that is at play here. This is really automated. The throughput is increased, and in fact, we have some customers, in particular in the dental market, which are using our technology in very high volume application, and the productivity overall of the process is increasing also significantly. In fact, we spend time, and I think the previous speaker spoke about the fact that people don't buy machines for the fun of it, but ROI is absolutely critical. Absolutely. When you move to production, you need to make sure that your total cost of ownership and your ROI is actually making sense. And this is really what we work with customers with. Here, there is an example on this slide of a customer which is printing SLA parts, 350 trays per week. And obviously the current process uses a lot of labor. So by actually taking the labor out, we save a number of euros per tray. We also typically have technologies, because it is controlled, that have longer longevity. So you don't need to change the detergents as often as with the traditional IPA or TPM fluid that are used for SLA resin removal. And there's also the additional cost of our detergent. So overall, in this case, a ROI of about 44 weeks for this specific application. In general, ROI with our technologies are very often below 1 year, sometimes in weeks, rare cases above a year, but typically you are in the less than a year return on investment because of the labor component that you can take out. Clearly, once you automate using digital technologies for the post-process phase, you also benefit from a number of elements that really enable additive manufacturing to insert itself in a truly modern digital manufacturing environment. Obviously, the automation ensures that you control the process parameters. So you digitize this tribal knowledge that is currently at play in post-printing. You can make also data-driven decision using prediction, using machine learning, basically using all what data-driven processes enable. And most importantly, it makes your additive manufacturing chain an integral element of a comprehensive manufacturing shop floor. There are going to be companies that will have additive manufacturing in addition to traditional manufacturing. And as I said before, they will not lower their standard. So ensuring that you have an entire additive manufacturing workflow, which is digital and that can integrate in an overall manufacturing workflow, is also absolutely critical. This is what data-driven post-printing enables. And with that comes also a number of additional benefits. The fact that you can actually operate and monitor from anywhere, anytime. With our technology, for instance, you could have a distributed manufacturing process with different manufacturing plants using exactly the same recipe to finish the parts, because you don't need to train someone. You just exchange a data file on how to actually finish a part. So you can operate a true global distributed manufacturing network. Obviously, optimizing the finishing of the part based on the design of the part, and like I said, informing the design of the part on how to optimize the finishing. Ensuring that you can do real-time planning and decision-making. You know, because it is data-driven, when your post-processing operation will stop. And you can completely optimize your planning and your work job based on this type of information. So overall, this full automation enables the scaling to millions of parts per year. So this is a real view of how we see post-printing integrating into a truly digital manufacturing process, where data is at the heart of the design, at the heart of the printing, and at the heart of the post-printing, where connecting data streams across the entire process ensures that you provide true transformation for additive, enabling additive manufacturing to move towards large-scale manufacturing. That's the end of this presentation. I think we could have some time for Q&A.
Well, first of all, let me thank you, Bruno. Thank you so much for the presentation. Let's head over. I see the most voted question as of now is, what's the best next step a 3D printing service bureau can take in order to use post-processing smarter?
So obviously, the way we operate with customers, typically the customers present us their print technology. What is their biggest challenge? What is the one process that they would like to automate because this is their number of parts that is scaling, for instance. Then we typically work with customers on a benchmark and do some of the calculation that we have discussed about, including ROI, which is very often something that we spend time with the customer, and off we go.
And then the next one being, please tell us more about solutions developed exclusively for metal AM space, whether support removal process can be automated.
Yeah, so support removal in metal is not an application that we have focused on. We do a lot of surface finishing on metal, and with all the usual suspects that you find in metal, from titanium, Inconel, stainless steel, aluminum as well. So, but mostly on surface finishing. This is where, and also powder removal. This is where customers are asking us help at the moment.
I see. And next one, use your technology in a demo format to try it out?
Yes, we have some possibilities to do demos. In fact, we are doing some at the moment, both in the US and in Europe. And this is something that we can discuss directly.
Perfect. And next question is, are all your processes chemical-based, or do you automate manual processes too?
I'm sorry, I didn't get the question.
So are all your processes chemical-based, or do you automate manual processes too?
So we use basically what you need to do when you want to finish a part in an automated way. You need to remove the excess material that has been put during the printing, because printing is basically you add layers or powder, but you have excess material, and then you need to remove it to get back to the intended design. So in order to do that, you need to put energy, and there's two energies that we provide. One is mechanical energy. That can be provided by media, for instance, which is in contact with the surface, or that can be provided by cavitation, by a movement of fluid. But there's also chemical energy. So this is a combination of both, sometimes only mechanical. There's always some mechanical energy, even when we have some chemical energy, but it's a combination of both that actually gets to the result.
I see. Another one focusing again on materials. I guess you covered the metal part, but the question is, what materials do you cover? Ceramics, metals?
So we do metals, as I discussed. We have not had so much experience with ceramics, but we've had some. But as you know, there's not that much ceramics printing at the moment. I must say that most of the customers at the moment are asking help on polymer, because polymer is really starting to scale in large volume. But we also have some metal application which are in significant volume at the moment, but a lot of for instance help needed on SLA, in particular with the need to replace some chemicals like IPA, for instance, which is used right now in SLA, and which is not a very friendly chemical. So we have much more customer-friendly chemicals. So there's a lot of requests for that. A lot of work on polyjet, a lot of work on FDM. FDM support removal can really become a very big bottleneck in manufacturing operation. In fact, one of our customers, the Toro company, just did a webinar on this recently. And also a lot on powder, MGF, SLS as well.
Okay, thank you very much. Next question is, can you evaluate the health and safety impact of your automated solution?
Yes, so we are working, obviously, and it's particularly true as you integrate into a manufacturing environment, right? When you do prototyping, sometimes stuff is a bit hidden, it's low volume, your health and safety people don't really get involved too much. In our case, because we scale, we really are dealing with the professional people at the customer, which are in charge of ensuring that material are used in a safe way, compliant with obviously all the stringent and quite variable legislations around the planet. So we really pride ourselves for really placing a very high attention on that. And I can say that we have some of our technologies already in use in some of the most demanding territories around the world for health and safety requirements.
I see. Well, I guess this one is along the same lines, but what about the residual material after the process? Is it a health and safety critical medium?
Yeah, so that depends. It's obviously you have always to make sure that you are compliant with your local requirement, and in some cases, in most cases, using what is already being used to remove residues of the current process, the current printing process, is sufficient, and sometimes actually you need much less precautions than that.
I see. And which size of parts can you handle?
So we have some big envelope post-printing equipment, our base equipment, for instance, which is used a lot for FDM application in automotive, where sometimes you have really big parts. You can actually post-print close to, it's slightly below 1 meter parts, so big parts.
Fair enough. And I guess the last question is, do you remove material? Is there enough material removal that you require stock to be added to the model?
No, we obviously optimize the process to remove what is needed to get back to the intended design.
Fair enough. Well, Bruno, thank you very, very much. If you guys have any further questions, you can find the post-process team on the 4th floor, table 7. Bruno, merci beaucoup. Thank you very much. And
Thank you.
We'll see you guys all in the networking session. Thank you so much.
Okay, thank you very much.
Cheers.
Bye-bye.